Welcome, Pre-Calc Honors students, to inverse functions. Now let's take an example right away. This is the doubling function. It takes 1 to 2, 2 to 4, and 3 to 6. Its domain is 1, 2, 3, and its range is 2, 4, 6. What's the inverse of this function? Well, the inverse should undo what we had before. So it should take 2 to 1, 4 to 2, and 6 to 3. Switching the roles of the domain and range. With the new domain of 2, 4, 6, the range 1, 2, 3. So if our original function was f of x equals 2x, the doubling function, then the inverse function, denoted by this negative 1 power, is x over 2. There you go. That's the idea of inverse functions. They take you back to where you were. Now, just a little note about this notation. This actually does not mean to the negative 1 power. It's an unfortunate use of this notation, but it's been pretty much standard all the way along, so get used to seeing that that's the symbol for inverse. Now, what's the inverse of f of x equals 2x plus 3? So by the same thinking, a lot of kids say, well, f inverse of x equals 1/2 x minus 3. So let's check it. F of 3 is 2 times 3 plus 3 is 9. So f inverse of 9 would be 1/2 9 minus 3, or 4.5 minus 3, or 1.5. It did not take us back to 3. So this is wrong. You can't just take the inverse of each part when you're trying to think in the inverse of a composition of two functions. So let's put the big no on this. And here's the fallacy in the thinking, and it's as logical as this worker from a long day at the chemical plant. Let's see what's going on with him. He really wants to enjoy skim milk, but how? In the morning, he put on the mask, and then he put on his hat. So now in the afternoon, what has to happen? He must take off the hat, then take off the mask. He has to do the inverse operation on each thing in the inverted order. So let's revisit our little attempt at finding the inverse of f of x equals 2x plus 3. We multiplied and then added 3. So now for the inverse, you have to do the inverse operations in reverse order. So the last thing we did was adding 3. So now the first thing we have to do is subtract 3, and then the first thing we did was multiply by 2. So now the last thing we do is divide by 2. There's the inverse function. And here's how we prove if two things are inverse functions. The composition in each direction should make x, either way we do it. So we had f of x equals 2x plus 3, and here's our proposal for the inverse. G of x equals x minus 3 over 2. G of f of x is g of 2x plus 3. So now we put 2x plus 3 into the g function. We get 2x over 2, which is x. You also have to check the other direction. F of g of x. F of x minus 3 over 2, which is twice x minus 3 over 2 plus 3. So that's x minus 3 plus 3, you get x. So this verifies that these two are inverse functions of each other. Now here's a nice technique where you don't have to sort of eyeball it. You can just do it directly, algebraically. Replace f of x with y, switch the roles of x and y, solve for y, this is f of x. Let's see how this works on our next function. X cubed minus 2. So step 1, replace fx with y. So we have y equals x cubed minus 2. Now switch the roles. And what I'd like to do is put a little dash line in here, because we are tripping over inverse land. This is inverse land. It is not the same function anymore, because we have switched the roles of x and y. And now we solve for y. So x plus 2 equals y cubed. Y cubed equals x plus 2. Y equals the cube root of x plus 2. And there's our inverse function. F inverse of x then is cube root of x plus 2. All right. Let's see how this looks visually. Here's our original function, y equals x cubed minus 2. And here's the inverse, x equals y cubed minus 2. Notice how they have mirror images over the line y equals x. And so many things change. The x's and the y's change for not only the equation, but any single point. You could look at a point on here like 0, negative 2 turns into negative 2, 0. Or it looks like 6, 2. Yeah, 2 goes to 6, and now 6 goes to 2 on the inverse function. Let's find the inverse of f of x equals, well, let's make this a little more complicated. Pause. Here we go, 2 minus the square root of 6 minus x. Well, our first step, let's get it equal to y. Y equals 2 minus the square root of 6 minus x. And so x equals 2 as we trip over the inverse land. This is also supposed to mimic the dashed line y equals x that we're flipping it over. 2 minus the square root of 6 minus y. So x minus 2 equals negative square root of 6 minus y. So x minus 2 squared equals negative square root of 6 minus y squared. So x minus 2 squared equals 6 minus y. So y equals 6 minus x minus 2 y squared. And so f inverse of x equals 6 minus x minus 2 y squared. It all seems well and good, but when we actually go to GeoGebra and look at this, we have a problem. We have a problem because six minus x minus 2 quantity squared is the full parabola like this. And the one we want should not be so complete. These are not mirror images over the line y equals x anymore. We have to put a restriction on the domain of this inverse function so that it's the true inverse of this other function. So that's why I made this orange function, which is basically the parabola, but only for x is less than or equal to 2. And so that's what we're looking at now. So what went wrong with our algebra? And why didn't we catch this? Well, let's insert a page in here and see what happens when we do the composition of these two supposedly inverse functions. We're claiming that f of x equals 2 minus the square root of 6 minus x. And g of x, the inverse, is 6 minus x minus 2 squared. So let's put these inside each other. F of g of x equals f of 6 minus x minus 2 quantity squared. So that's equal to 2 minus the square root of 6 minus x minus 2 quantity squared. Like that. 6 minus minus cancels, we get 2 minus the square root of x minus 2 quantity squared. And so we get 2 minus the absolute value of x minus 2. That does not equal x. Okay. If x is greater than or equal to 2, then we can ignore the absolute values. And we get 2 minus x plus 2, and we get 4 minus x. That doesn't work. If x is less than or equal to 2, then we get 2 minus x, because it would be the opposite of what it was, and we get x. So we need this restriction on our inverse function. So getting back to this now, watch what happens with each of these. Our original function was a function. Our original function was f of x equals 2 minus the square root of 6 minus x. Its domain was restricted by the 6 minus x in here. The domain was x must be less than or equal to 6. The range, you can tell from the graph, we have all the points from 2 down. Y less than or equal to 2. So now when we do the inverse function, f inverse of x, we cannot just simply say 6 minus x minus 2 squared. This will be the full parabola with vertex at 2, 6, negative concavity, so it's coming down. But that would include the stuff over here. We'd have to say 4 x's less than or equal to 2. So we impose the domain restriction on this parabola so that it can be inverted. So the domain is x less than or equal to 2. The range, as you can tell from the picture, we have things from the vertex down, 2, 6. So the y values are less than or equal to 6. Notice the exact switching of the x and y, not only in the equations, not only in the points, but also in the domain and range. Flange out.